Here, we provide you a NumPy notebook to do a basic image processing using NumPy. If you're looking for the notebook, to locate it, you need to go in your week 3 folder and find the satellite image analysis notebook. And please locate the Wi-Fi folder with the data in there as well. So we picked satellite imagery because satellite imagery is a very interesting image data to exercise this. Okay, you can go and read about all the image, the data source, where it comes from, the Wi-Fi system here. I'll go to the next line here, where we gather our tools together. Like our other notebooks, we'll start by importing NumPy as NP and SciPy and Matplotlib in this particular case. So I go ahead and run that using Shift-Enter. Next, we will read our satellite image as an ND array using the IMRead function. So this function is provided to us by Python. Here we say we import the data package, and we'll use the IMRead function, and that's the Wi-Fi folder with this 3-layer image we'll be working with that you have there. And if we look at the type of this data, we'll see that it's an ND array. As we talked about before, this is an RGB image. And the type is ND array because it will be turned into an ND array with 3 dimensions. We use the type function to display that type, but it just shows us ND array, of course. Let's now plot the image in our notebook to see it before we do anything with it. We first set up a frame size of 1515. You can change that frame size the way you like if your notebook is higher resolution and things like that. And we'll use the IMShow function in SKA image to display it. So let's run this. We see that image shows up. That's great. We see our colorful satellite image now. But what are the dimensions of the ND array, right? I said it's a 3-dimensional one, and we need to use the shape function. Type function won't be enough for that. Let's run photo data, which is the name we gave to this array, and shape as a function. We see that 3725, 300, 725 is the height, and width is 4797, and it has 3 layers for RGB. Those are our 3 layers. There's something interesting about this image. Like many other visualizations, the colors in each RGB layer means something. For example, the intensity of the red will be an indication of altitude of the geographical data point in the pixel. The intensity of blue will indicate a measure of aspect, and the green will indicate slope. To a trained eye, to a geoscientist or a field modeler, these colors will help to communicate this information in a quicker and more effective way rather than showing numbers. So if we had to show the numbers, for example, let's go to the in4 line and uncomment that print function. We would see a bunch of numbers. It really doesn't indicate much if we didn't have to use that. If we had to just interpret those numbers, it would be difficult. Whereas by just looking at this colorful image, a trained eye can tell already what the altitude, what's the slope, what's the aspect. So that's the idea of loading some more meaning to these colors to indicate something more scientific. Okay, once we load the image, we can start exploring with it. Let's check its size. We'll use the size function of the ND array for that. And like many other things we do, we'll check the maximum and minimum of the data values and maybe the average pixel value. Here, we use ND array's minimum function and maximum function. These values are important to verify since the 8-bit color intensities cannot be outside of the 0 to 255 range. Using the ND array or the image, the photo data variable, we can check the RGB values for a pixel in the image as well. For example, we'll check here the row 150 and column 250. What are the RGB values at this column? I'll use photo data, 150, 250 here. And we'll see that the values are 17 for R, 35 for G, and 255 for B. So this particular pixel has a lot of blue in it. We could have also selected one of these values, like if we want to select the green, photo data 150, 250, 1, 0, 1, 2, the indexes, remember. So this gives us the second one. Index 1 will give us G, the green value. So if I run that, we'll see that green value is 35. That's great. So these are typical ND array functions in NumPy to work with the data. Similarly, we can change individual values of each pixel by assigning specific values to pixels. Here, in this line, I'll go and set that pixel that we just worked with, row 250, column 250, to be 0. In this line, photo data 150, 250 equals 0. We just set all 3 layers to be 0. So this image to be particularly black. Of course, we can display this image now using, again, the figure plotting and IMShow. But it won't change much and be visible because we only changed a single pixel, which was this 150 to 250. It was somewhere around this. We can also try to change a range of pixels. Let's try to do something bigger and set the values of the green layer to full intensity for all columns within the low range of 200 to 800. So row 200 to 800. So it's like it should show horizontally, something like this. We'll set every value from row 200 to 800 in all the columns, as we see in this range query, to 255. And only the second, the green layer, RGB, one associated with green. So just pause a second and think, what would you expect to see? We significantly increase the green value in these pixels. And it's, again, from row 200 to 800 for all the columns. So you would expect, I hope, to see that horizontal range or a big bar that looks greenish than the rest of the pixels around it. So let's run this. And we'll indeed see from row 200 to 800 for all the columns, we have a higher green intensity. So our range assignment worked there. Similarly, we could have set the range. I'll reload in this first line. I'll reload the image because we just changed the image. I want to set it back to its original. So I reloaded it using IMRead to photo data again. And here what we are doing is we are setting all the columns and all the layers. I didn't particularly give another one of the 0, 1, 2, one of the 3 layers here. All the columns in the range 200 to 800 for the rows to be of full intensity. What would you expect to see? I hope it's white because all 3 colors are fully intensified, so that shows up as white. If we run this, indeed we see that white bar there. Of course, we could have done black by setting, instead of 255, the all 3 layers to be 0. So we are muting down all the colors. Please now stop the video and play with the range and RGB values to make yourself comfortable with this notation. We will be using this notation quite a bit for the rest of this notebook, so it's important that you understood everything up to this point. Okay, now let's go to our next line. And we'll start creating a Boolean ND array in the same size by using a logical operator. So we'll check the values of these pixels. Like I've done before, I'll first reload the image to photo data, since we changed it a bit again. And I would like to use the original image for the rest of the notebook. Let's print the shape of it. I'll say shape of photo data and its shape. And here in line 3, we use a comparison to select all values that are less than 50. This will create a Boolean ND array of the same shape with our original array. Now that we have it, we can use this new ND array, like we did before, to filter out pixels with low intensity, or I can call them points of less interest. So let's run this filter. We see that shape of the photo data is equal to the shape of the low value filter. And we generated that low value filter using a global comparison operator for all the values less than 50, right? So how do we do filtering using this new low value filter array? Maybe we'll now use this array as an index to set those low values to 0. So here, what we do is we have our original data, right? We'll show that first. Then we'll apply this filter of low value filter in our 4th line here to be 0. Actually, we are not using the random here, so we can get rid of it. But if you'd like to add a random, please uncomment that later. And then after we apply the filter, we'll plot the image again and see if there's any difference. This is our first image, the original image. And the next one, we apply that filter. So although it's not very visible, at least to our bare eye, there is a little intensity change in this figure. But let's go back to the filter and set it to 200 and do the same thing. We'll see that the image will really change. So instead of less than 50, let's set these to be 200. Okay? So now our low value filter is not quite a low value filter because we have quite high values that we are filtering there. Anything less than 200, there's only 255. So we have that new filter, and we are running the exact same thing. We are applying this filter to photo data. This was our original image. And we see that the next image filtered out a lot of those pixels with low values for RGB, or values less than 200 in this case. Okay, now let's do some more operations using the row and column indices. Here, what we'll do is we'll create range arrays. So it's going to be 2 of them. One of them will be for rows. So we'll get the length of the photo data. And we'll use the aRange function to create these 2 arrays. And they'll be of class numpy ND array. So we create a range array called rows_range in the first line. We assign that same array to an array called columns_range. And these arrays in the next cell, we use these range arrays to set the values of the pixels associated with them to have full intensity in all colors, which means to make the color of these pixels white. Now if we plot this image, let's go back to our notebook. We'll have photo data here. We are using rows range and columns range. We are using these two range arrays and setting all the values in those pixels to 255. Now let's show our image. We'll see a diagonal line, white line, because those are the values we set, going through a virtual square in the left part of the image. Here we see that's exactly what we've done, right? We had a range array for the rows and a range array for the columns, and we set those as indices to this matrix and said right here, we said assign those particular pixels 0, 0, 0, 1, 0, 0, 1, 1, 2, 2 to be 255. And we see that as a diagonal line, a white line from 0 to about that 3700 range that we had in the image.